Thanks everyone for joining today. I'm going to present you the enhancements that we have made in HyperWorks HyperMesh 2024.1 for the explicit solver interfaces and safety tools. So as part of the agenda today, I will discuss and show you first the mass balance workflow. This is a new workflow that we introduced in this release. This workflow is actually not only for the safe solver explicit solver interfaces, but for more than that, I will explain you more in details. But the explicit solver interfaces will show you the important updates we made for the radios, LS-DYNA, and pump crash interfaces, and finally the safety solutions, introducing the new bus rollover workflow for the EC ERT66 regulation, and some enhancement we made also in the Seatbelt tool. So let's start with the mass balance workflow. So the mass balance workflow was actually expected in HyperMesh for a very long time by many customers. So now it's available. So we implemented it, as I said, not just for the explicit solver interfaces. So it has been implemented across multiple interfaces. It's implemented for OptiStruct, Nastran, Abacus, radios, LS-DYNA, and pump crash interfaces. So what's the mass balance workflow allows you to do? Basically, it's automatically distribute masses on nodes or properties or components or parts, depending on your selection, to match user-defined target masses and or COG that you may give for the selection you have made for the calculation. And we expose also from this workflow visualization of initial and final values like COG position, final COG positions, and the initial and final values after the balancing application, so that the user has the overview on what the workflow has achieved and the final results compared to the initial one. So as part of the workflow, as I said, we can create and distribute masses on nodes. In that case, you see the different entity types which are created per interfaces. So for OptiStruct Nastran, we create the CONM2 elements. For the Abacus interface, the element type mass and mass properties. For radios, we create the add mass type 5, DYNA element mass, and pump crash the mass elements. If the user selects to distribute the mass on properties or part masses, so depending on if you're in the implicit or explicit solver interfaces, you will have different entity created. So for OptiStruct Nastran, it will create a non-structural mass NSML1 per property. Same for Abacus, using the non-structural mass per property. For radios, you will have the add mass type 6 created, for DYNA element mass part, and for pump crash the NS mass per parts. So I have prepared 2 recordings to show you the workflow here. For example, in starting with LS-DYNA. So here you see the choice that you have between nodal and part mass type selection. You can activate also the display option for COG, and in case of the nodal mass, you can also activate the nodal mass distribution at the end of the workflow. So basically here, this is a standard workflow on a vehicle for adjusting the mass and the COG. So you calculate the mass of the full vehicle and decide to adjust the mass on selecting some components on those will be the mass distributed. So you see in this GUI, you have the first initial values which are calculated, so that, and then user can give the target values for mass and COG. Those values will be used by the mass balance workflow to be the target. And once you balance, you have the final results. As you see here, mass balance is done. You see the mass distribution, and at the end, you see the element mass entity created, in that case on 30,000 plus nodes. And you can at the end also verify that again the final mass of the model and final COG is as per the targets given in the workflow. Another example for OptiStruct. Here as well, using nodal masses. So here directly the target components for the mass distribution is in that case automatically selected as the one that has been selected for the calculation. And you get the mass balance done in a similar way as for the previous one for LS9. Just in that case, you have mass elements, so CON-M2 elements, which are created on the nodes. And here as well, you can verify the final mass, which is in perfectly matching the target values. I need to also to mention that this workflow is very fast, as you can see in the recording. So the time that you get for the balancing of the mass on the nodes is the real time. So there is no much delay. It's a very fast workflow. Another comment that I can give also on the difference between applying and distributing the mass on nodes or on property or components. You may know that if you balance the mass on nodes, like in that case, you will have at the end a very much quality in terms of final results compared to the targets, because you have much more, let's say, degrees of freedom to balance the mass in the space. If you do balancing on properties, you have, of course, in that case, less degrees of freedom of balancing the mass. So at the end, the balancing will work, but you may not get a perfect matching with the target values. They will be close, but maybe not 100%, as the case when you use nodal mass distribution. So this was, I would say, the major workflow that we have added in this new release. And so moving forward to the explicit solver interfaces, I will not go through the details of all those points. I will just mention the key points. So starting with the radius interface, one of the major requests was the enhancement of the unit conversion workflow to consider the begin card and the engine keywords, which are not all perfectly supported. This has been enhanced and it is now working perfectly. Concerning the contact keywords for all HyperCrash users, we made also an enhancement in the display of some attributes like ISTF, which is now showing the values as it was the case previously in HyperCrash. So this is finally done. And on the creation of new contact, so we now expose the type 19 as default directly to the user and not more type 1, so that the user may use this one directly and not change the the card image and so on. So small changes, but asked for a long time by many customers. In terms of keyword support as well, we did a good amount of keywords updates, new keywords implementation. I will not go through the details here, so you refer to the release notes, please. But there are quite good numbers of those one based also on customer request. Model checker, a few enhancements, also based on a customer request to check and detect merge rigid body keywords with unresolved nodes and element IDs to enable to fix them quickly. And in terms of issues fixed, also the key one, the most important one based on customer feedback. As you can see here, I would say mainly the second one was affecting one of our key customer for radios, which has been fixed. So when you use submodels with ID offsets in combination with rigid body collectors, there were some, ID conflicts and was sometimes messing up the deck. So this is now corrected. For the rest, I think you can go through those points and refer to your customers if they are affected by those changes. Concerning the LS-DYNA interface, here as well, we have improved the interface to support the latest solver versions. So the version AR40.1 and the AR15.0, together with as well a good number of keyword update and new keywords supported. So I here as well refer to the release notes. Small enhancement in the find attached tool, where now we have additional checkboxes to control the consideration of the constraint extra nodes and constraint rigid bodies in the search algorithm. They were initially considered, but there were no control to activate or deactivate those entities in the search algorithm and in the workflow. So this is now added. And in terms of relevant issues fixed based on customer feedback, I would say these are the most important one. The first one was quite important, related to the set collect handling. So basically in HyperMesh, we were handling those sets correctly when we were loading the model at once in HyperMesh. But at the moment the user was importing the include files, for instance, one after the other, the logic was not implemented to reconcile and group together the collect sets as they should be. So this has been corrected and now it's behaving as expected. The correction about the constraint interpolation elements when we create this element was also an important one, because the way we were defining the default weighting factors using a 0 value is actually wrong. The behavior of the solver in that case is not the expected one. The expected one is when you have default values equal to the first weighting factor. So this has been changed. We now affect the correct value, and we have added a model checker to automatically detect this configuration and let the user give the possibility to the user to automatically correct such constraint interpolation elements via the model checker. And beside this one, I think the others are also important and were reported by customers. Some import and export issues for some specific models. The PAM crash interface is also evolving. So we have aligned the interface regarding set segments, which were not yet used in a PAM crash. They are now introduced to support the ACG and EGG entities, previously HyperMesh elements. They were previously not really easy actually to handle, to create, and so on. So now through this migration, we have the full-fledged of creation and handling of those entities via the set segment, as it is done, for example, in radios and LS-DYNA and other interfaces. So you can now create the ACG elements, which are the surface segment, or the AGG, which are the edge segments, directly from the set segment entity. As part of the find attached tool enhancements, this is an enhancement that has been made also across other profiles, where now the introduction of the include the tight contact treatment also in the search algorithm which was already implemented in LS-DYNA and Radius interfaces, but not in PAM-Crash. Same has been done also for OptiStruct and other interfaces, and I think Abacus as well, and where the tight contact is important for the find attach logic. Plus, in PAM-Crash, you have the introduction of the link elements. So you have an additional option checkbox that you can activate to consider those specific elements for the search of attached entities. So let me switch now to the safety solutions. So where we have added, again, a new workflow, a new tool to continue enhancing our portfolio. So this is now the bus rollover workflow, which covers the ECE AR66 regulation. This was a request also that was made last year by some customers from the field and that we have considered for this release and which is now available. So the ECE AR66 workflow allows the user to automatically create the impact load case include file for the simulation of the bus rollover impact load case. So for that, the workflow does automatically the calculation of the unstable position of the bus and the platform. It does the calculation automatically of the impact position of the bus just above the ground, and you have also an option to create or not the ground. If it is not already predefined in the model, you can let the tool create the ground, and yeah, that's pretty cool. So basically, you get at the end of the workflow an include file which defines the load case. Anything else, like contact, control cards, anything that needs to be considered for the simulation needs to be predefined in the model. The workflow here is just designed to create the impact load case include file. And this tool is implemented for the Radius, LS-DYNA and PAM-Crash profiles. So here you have a quick recording showing how the workflow works. So first you select the bus, you select the platform. These are the mandatory selection. If the ground exists in the model, you have to select it. Then moving to the unstable position calculation. So there you need to define the pivot points of the platform, define the rotation axis of the platform, give this initial COG value, so it can be given manually or calculated in the workflow directly, as you can see. And define the unstable position. Then you move to the next step, which is the impact position, where here as well you have to select now the pivot for the impact and pivot axis, so that the bus now will rotate around this axis to fall on the ground. So that's the final position of the bus, just above the ground. And last steps in the workflow is the creation of the load case card. So basically initial rotational velocity, some parameters, gravity, and so on. And you have also the possibility through this legend to visualize the different values like the angles and distances that have been calculated during the process. Right. So at the end of the workflow with this include file, you should have everything set up for the simulation. For the Seatbelt tool, we are actually in the process of doing some important enhancement in this tool. So this is just the first set, I would say, of enhancements. Others are still ongoing. So the these are the few points that we have achieved for the 24.1 release. So the first one is we allow now to create more than 2 cross sections on the seatbelt segments. We have updated the possibility to change the control point location by picking the nodes directly on the control points instead of redefining the complete seatbelt segment path, which is much easier now. For LS-Dyna specific, we have now the consideration of the null beam component when we extract the belt. So this is specific when the customer wants to use the seatbelt tool in HyperMesh and the belt is coming from another preprocessor, so that you need to extract the belt. And with this enhancement, we now consider more those specific beam components on the seatbelt. And yeah, another one which was a bit annoying for some customers, the fact that when we deleted the seatbelt entity in HyperMesh, it was also deleting also the solver entity. So the complete seatbelt was deleted, not just the metadata. So now you have a checkbox, or not a checkbox, a message box that will appear for the customer, to the user, where he can decide to keep or not the solver entities when deleting a seatbelt. Just to showcase you this enhancement here on the LS-Dyna interface. So here you see a seatbelt model which is coming from another preprocessor. You don't have the seatbelt entity in HyperMesh, so you can extract it. So this is the extraction of the belt. The tool was already in HyperMesh, but now, as you can see, when we extract it, we have those beam elements that you see on the seatbelt mesh are automatically recognized and defined in the belt, so that once you modify the belt path, so for example here we can pick a new node for the one control point, the seatbelts and the beam elements are considered when we update it. The other one, creation of multiple cross sections. So we have enhanced this GUI, this controller to allow more than one cross section. So you see now you can, like in this example, create, for example, 3 cross sections from start and 3 cross sections from the end of the belt segment automatically. So those are, let's say, the few enhancements that we have achieved for this release. Regarding the next enhancements which are ongoing, we are actually working on new functionalities to create a full meshed seat belt, so completely in 2D with 2D elements, to get physical quality from the seatbelt final mesh. We are working on a new process to do that, and which is because those are now more or less the standard type of belts which are used by OEMs. So we need to improve a little bit our process to generate this type of belt. So this is pretty much the next steps for the update on the seatbelt tool. And I would say that's pretty much all from my side today.